This is the Module 1 EOC review. The first thing we talked about in Module 1 were sequences, and we determined if a sequence was arithmetic, geometric, or neither. This particular sequence, we are adding 2 each time, which makes this an arithmetic sequence. In this sequence, we're multiplying by 2, which would make this a geometric sequence. This sequence, it looks like we might be adding 2 or multiplying by 2, but neither of those work for the third term. So this sequence is neither arithmetic nor geometric. Now you try numbers 4 through 6. Number 4 was neither arithmetic nor geometric. Number 5 was geometric, and number 6 was arithmetic. The next thing we did was write the explicit formula for the sequence. In order to write the explicit formula, we have to determine whether the sequence is arithmetic or geometric. In this sequence, we are subtracting 10 each time, which makes this an arithmetic sequence. So the explicit formula is A sub n equals A1, which in this case is 1, plus n minus 1, and then times your common difference, which is negative 10. This sequence we're multiplying by 5, which would make this a geometric sequence. So the explicit formula for a geometric sequence is A sub n equals A1, which in this case is negative 0.2, times your common ratio, which is 5, with an exponent of n minus 1. Now you try numbers 8 and 10. Number 8, the explicit formula was A sub n equals 4 plus n minus 1 times 100. Number 10, the explicit formula was A sub n equals 4 times 2 with an exponent of n minus 1. The next thing we did was find a certain term of a sequence. In this case, we would write the explicit formula and substitute in the term number for n. So this formula we are subtracting, or this sequence we are subtracting 3 each time. So it would be arithmetic. So we would use A, and instead of n, we would use 52. 39 is our A1. Instead of n, we would use 52, and our common difference, which is negative 3. We could then type that in our calculator and get negative 114 as our answer. Now you try number 12. The 52nd term is 432. We are looking for the 8th term of this sequence. We're multiplying by 4, which makes it geometric. So you would again replace n with 8. So we get a sub 8 equals a1, which is 4, times our common ratio, or a1, which is 1, excuse me, times our common ratio, which is 4, and we would use 8 minus 1 as our exponent. And when we put that in, we get 16,384. Now you try number 14. You should have gotten the nth term as negative 156,250. The next thing we did was finding missing terms of sequences. In this case, they have to tell you whether the sequence is arithmetic or geometric. In this case, it's arithmetic, so you do the last minus the first term we are given over 1 more than the number of blanks or 1 less than the number of pieces, including the 2 end terms. So in this case, we get 12 over 3, which reduces to 4. So our common difference is 4. So when we add 4, we get negative 1. We add 4 again, we get 3. And if we add it, we see that it works with 7. You try 16. You should have gotten negative 90 and negative 190. We can do the same thing with geometric sequences, but instead of subtracting, we divide. And we raise it to an exponent of 1 over 1 less than the number of terms we have. So this would be 8 to the 1/3, which gives us 2. So our common ratio is at 2. So we multiply negative 4 times 2, we get negative 8. Negative 8 times 2, we get negative 16, and we see that it works for the last term. You try number 18. You should have gotten 12 and 36. Another thing we did was series, which are sums. So the keyword in these problems would be sums. When we're looking for a sum, we would use a sigma notation. And we're looking for the sum of the first 15 terms. So we go from 1 to 15. And we use the explicit formula for this sequence. So in this case, we're subtracting 4, so it's arithmetic. So we do a1, which is negative 3, plus n minus 1 times our common difference, which is negative 4. We can type this in our calculator. Remember, you can go to Math 0 to get the sigma notation. Also remember, you have to use x when putting this in your calculator, no matter what variable you have on your paper. In this case, we get negative 360. For this problem, the directions are the same. So the first 15 terms. So we go from n equals 1 to 15. But this time, the sequence is geometric. So we start with a1, which is 4. Our common ratio is negative 3. And we use an exponent of n minus 1. We can also type that in our calculator. and we get a very large number. These numbers can get very large or very small. Now you try numbers 20 and 22. For 20, your answer should have been 330. And for 22, your answer should have been this very long number. The last thing we did with series was finding the sum of an infinite geometric series. This formula is not given to you. First, you have to find the common ratio. If you can't figure that out, you can take the second term, so in this case 2/3, and divide it by the first term. So I would type in my calculator 2/3 divided by 4/3. And when I do that, I see that my common ratio in this case is 1/2. And the formula is the sum is equal to the first term, which in this case is 4/3, over 1 minus the common ratio, which we said was 1/2. Again, I can type that in my calculator. When I do that, I get 8/3. You try number 24. Your answer here should have been 7.5.